Chapter 2, Integration. Subtopic 2.1, Integration of Functions. At the end of this lesson, students should be able to relate integration and differentiation, define the basic rules of integration, find the integral of e power bx plus c, 1 over bx plus c, and a power bx plus c.
The first part is integration as anti-differentiation. The process of finding antiderivative is called integration. Integration is the reverse process of differentiation. If ddx of fx equal to fx, then integrate fx with respect to x equal to fx plus c. Okay? And this symbol is called an integral sign, and c is called the constant of integration. A single function has many antiderivative fx, but the functions have only one derivative fx. There are two types of integral. We have indefinite integral, in which we are given the upper and lower limits of integration. Therefore, for final answer, we have plus c, where c is the integral constant. The second one is definite integral, in which we have the upper and lower limits, and the final answer will be a number. No more c, the integral constant. Okay, we go to example number 1. Given y equal to 2x plus 3 over 3x plus 2, find dy dx. Dy dx is the derivative, and hence, the word hence means we need to use the previous answer. Okay, so firstly, we need to find the derivative of y. And if we notice here, the function is in division form, meaning that we need to use quotient rule. Okay, so you need to recall your differentiation. Okay, we said what is u? U is 2x plus 3 and v is 3x plus 2. U prime is 2 and v prime is 3. Okay, don't forget to cross the answer here. Therefore, we have dy dx equal to 2 times 3x plus 2 and minus, for quotient rule, we have minus 3 times 2x plus 3 and divide by v square, 3x plus 2 square. Okay, and if we try to simplify, we will get negative 5 over 3x plus 2 square. Okay, so from the answer here, we can write d dx of 2x plus 3 over 3x plus 2 equal to negative 5 over 3x plus 2 square. Okay, so this is the answer for the derivative. Okay, next, hence find integral of negative 10 over 3x plus 2 square. So if we notice here, we have negative 10. Okay, the question is to find negative 10 over something. But here we have negative 5. Okay, so how to get negative 10? We need to multiply by 2. Okay, and then we need to integrate both. Okay, I write the integral sign first. So integrate, okay, with respect to x. The same thing for the right part. Integrate with respect to x. Okay, we want to find negative 10 over something. We have negative 5 over something. Meaning that we need to multiply both sides by 2. Okay, therefore for here we get integral of negative 10 over 3x plus 2 squared dx equal to, okay, so look at the term on the left. We have 2 times the integral of d dx of this. We know that integration and differentiation are opposite each other, isn't it? Okay, so we integrate something that we differentiate, meaning that we will get the original function. Okay, so we have, okay, don't forget we have 2 here. So the answer will be 2 times 2x plus 3 divided by 3x plus 2. We get the original function because we have integrate sign here, okay, integral sign, and then we have derivative of the function. Integrate, differentiate, okay, dia akan back to the original. Okay, and then don't forget to write plus c because the integral now is under indefinite integral. Okay, so we need to write the integral constant plus c here. Okay, and for the final answer, we can expand and we will get 4x plus 6 over 3x plus 2 and plus c. Basic rules of integration. Integrate dx, or we can write 1 here, okay, equal to x plus c, where c is a constant because this is indefinite integral. Integrate k, k is a constant, equal to, we can write k outside, k integrate 1 dx or integrate dx. C integrate x power of n equal to x power of n plus 1. Okay, so we need to increase the power by 1. Okay, so here power plus 1 and we divide by the new power. Okay, so integrate x power of n equal to x power of n plus 1 over n plus 1 plus c. D. Integrate k times fx dx equal to k integrate fx dx. We can take out k. And last one, integrate fx plus minus gx can be written separately. Okay, so we have integrate fx plus minus integrate gx. Now, we go to example number 2. Find the following integrals. A, we have integrate 4 dx. 4 is a constant. So, we will get equal to 4x plus c. If we have integrate e, exponent dx, the answer is ex plus c. If we have integrate pi with respect to x, okay, pi dx equal to pi x plus c. Okay, next part B. Integrate 3x power of 6 dx. 3 is a constant only, so we can write 3 integrate x power of 6 dx. We integrate x power of 6 with respect to x. So, we write 3 the constant times, okay, x, increase the power by 1, x power of 7, divide by new power is 7 plus c, or 3x power of 7 divide by 7 plus c. Okay, part C. Integrate 3x plus 2 times x squared. We have multiplication form here. And for integration, the most important word is simplify. Okay? So we need to simplify every question. Simplify first. Simplify and simplify. Okay? So we state the function in simplest form. And for this case, we can expand term by term. Okay? So we have integrate, okay, 3x cubed plus 2x squared dx. Okay, class. For integration, there is no product rule, no quotient rule. Okay, product rule and quotient rule are for differentiation only. Okay, so kalau dia dalam bentuk darab macam tu, jangan sekali-kali terfikir to use product rule. Because product rule is for differentiation only. Huh? Okay, so for integration, we need to simplify. Okay, now we try to get to find the integral. Okay, so we have 3x, okay, increase power by 1, divide by new power, plus 2x, increase the power, divide by new power, and plus c. Okay, done. Very simple, right? Okay, and part D, we have 1 plus ZY divided by y cubed in division form. Okay, as I told you just now, the most important word is simplify. Okay, so we simplify first and it becomes integrate 1 over y cubed plus ZY is y power of half divided by y cubed dy. Okay, and we can write as y power of negative 3. Okay, we write as negative index and plus y power of negative 5 over 2 dy. Okay, so if the variable is y, we will integrate with respect to y. Okay, and okay, as usual, we integrate. So we have y, okay, increase the power, so becomes negative 2 divide by new power negative 2 plus y. Okay, increase the power by 1, so we have negative 3 over 2 divide by negative 3 over 2 plus c. And final answer is negative 1 over 2y squared and then minus 2 over 3y power of 3 over 2 plus c. Next one is integration of ax plus b power of n. Okay, and then for this rule, we need to make sure that the function, okay, inside the bracket is a linear function. This rule cannot be applied for non-linear function. Cannot be applied for quadratic, for cubic and so on. Okay, so integrate ax plus b power of n, okay, equal to, okay, as usual, we increase the power by 1. So we copy the bracket ax plus b power of n plus 1 divide by, okay, the new power for this case is n plus 1 in general, and then times a. Okay, how to get a here? A is the derivative of the function, of the linear function, a here. Ax plus b. Differentiate ax plus b is a. So we have a. And coefficient of x is a. And plus c as usual. Okay, so we go to example number 3. Find the following integrals. Integrate 3x power of 5 power of 6. Okay. As I told you just now, for integration, we need to simplify. But for this case, we have power of 6. And which is tak sesuai untuk kita expand and write the term one by one lah. Right? Okay, so for this case, we will apply the previous rule. Okay, so we write equal to 3x plus 5. We copy the bracket. Increase the power by 1. So power of 7. Divide by new power is 7. And don't forget to differentiate the function, the linear function, and we will get 3. Okay, 7 times 3 and plus c. So final answer is 3x plus 5 power of 7 over 21 plus c. Okay, part B. Integrate 2 over 1 minus x power of 2, and we can write as negative index 2. Okay, we take out 2 outside. 2 1 minus x power of negative 2 dx. Okay, kita jadikan negative index. So equal to 2. Okay, copy the bracket. 1 minus x. Okay, increase the power by 1. We have negative 1. Divide by new power is negative 1. And don't forget to differentiate. Okay, differentiate the function. So we have negative 1 plus c. Okay, so the final answer is 2 over 1 minus x plus c. Very simple, right? Okay, next part C. Integrate for x minus 2. Set. Okay, set for x minus 2. Or this set function can be written as 4x minus 2 power of half dx. Don't forget with respect to dx. With respect to x. Okay, so we have 4x minus 2. Okay, half plus 1 is 3 over 2 over new power is 3 over 2. And differentiate the bracket, the function, we have 4n plus c. Final answer is 3 over 2, 2. So 4x minus 2. 3 over 2 divided by 6 plus c. Next, part D. Okay, we can write, okay, we can simplify as 4. Okay, integrate 4 times 4 minus x power of negative 5 over 2 dx. Equal to 4, the constant. Okay, copy the bracket 4 minus x. We increase the power by 1. So we have negative 3 over 2. Divide by new power, negative 3 over 2. And differentiate the function, the bracket. We have negative 1 plus c. And as the final answer, we need to simplify. And we will get 8 over 3 times 4 minus x power of 3 over 2 plus c. Next one, integration of 1 over x dx, 1 over ax plus b and f prime over fx. Okay, before that, okay, ingat balik, recall your differentiation. If we differentiate ln x, the answer is 1 over x, right? And we know that integration is antiderivative. So if we integrate 1 over x dx, okay, the answer will be ln x, the original function. Okay, so integrate 1 over x, the answer is ln x. And plus c. C is a constant. Integrate 1 over ax plus b equal to ln ax plus b and divide by a. Okay, mana dapat a? A is the derivative of the function. Ax plus b. We have coefficient of x is a. Okay, so we have ln ax plus b over a. And plus c. Plus c ni integral constant. Kalau dulu, kalau you refresh balik for differentiation, biasanya after we differentiate tu, kita akan darab, isn't it? But for integration, dia terbalik. Dia akan jadi over, macam tu. So, over a. Kalau masa differentiation, kita akan darab a, right? Okay, and the last one is the integral of f prime over fx equal to ln fx plus c. So, for this case, you need to remember. Okay, so you need to remember the rule. Example number 4. Integrate the following functions with respect to x. Integrate 2 over x dx can be written as 2 integrate 1 over x dx. Integrate 1 over x equal to 2 ln x plus c. Okay. One more thing. Okay, kalau for ln function, you need to make sure that the denominator here 1 over something. Okay, 1 over something here, the function must be linear. Okay, that is the rule. 1 over linear function will be ln. But if we have 1 over, let's say 1 over x squared plus 1, integrate, okay, 1 over x squared plus 1, okay, the answer is not ln. Okay, because the denominator is a quadratic, not a linear function. Okay, so we go back to example part B. 1 over 5 minus 3x. 5 minus 3x is a linear function. So, we will get ln 5 minus 3x divided by, okay, we differentiate the function, we will get negative 3. Okay, negative. Oops, sorry. We have negative 3. Negative 3 here. And plus c. Okay, next one. Integrate 3 over 2 times x minus 1. This is a linear function. So the answer will be ln x minus 1. Divide by, differentiate the function, we will get 1. Okay, so plus c. Okay, next one, part D. Okay, integrate 2 over x minus 4. X minus 4 is a linear, minus 3 over 2x plus 1. 2x plus 1 is also a linear function. And the answer is 2 ln x minus 4 divided by 1. Okay, differentiate x minus 4 is 1. Minus 3 ln 2x plus 1 divided by, okay, so we have 2x plus 1. We differentiate, the answer is 2 plus c, or 2 ln x minus 4 minus 3 over 2 ln 2x plus 1 plus c. Okay. Next one. Integrate the following functions with respect to x. So for this case, we will use the rule part C, which is we have integrate f prime x over fx dx equal to ln fx plus c. Okay, but we need to look at the pattern first. Nah? Okay, so refer your denominator. So we let as fx equal to x squared plus x plus 1. Okay, f prime x equal to 2x plus 1, which is exactly the same as the numerator. So this is actually your f prime x. Denominator is fx. So we can apply the rule. Okay. Therefore, integrate 2x plus 1 over x squared plus x plus 1 dx equal to, okay, look at the rule here. The answer is ln fx. For this case, ln our fx is x squared plus x plus 1 and then plus c. Okay, so that is the final answer. Okay, and part B, okay, we let fx, the denominator is 2x cubed plus x squared. And f prime x equal to 6x squared plus 2x. And if we look at the derivative, we have 6x squared plus 2x. But the numerator is 3x squared plus x. Okay, which is half. Okay, half of the derivative. Okay, so we can write integrate 3x squared plus x over 2x cubed plus x squared dx equal to half. Okay, because numerator is half of the derivative. Okay, half integrate 6x squared plus 2x over 2x cubed plus x squared dx. Okay, and if you try to simplify this part, okay, you will get, okay, the same as the question. Yeah? Okay, and we can write the answer now equal to, okay, so this is the pattern of the rule. So this is your f prime x and your denominator is f x. And the final answer will be 1 over 2, the constant, ln, okay, denominator is 2x cubed plus x squared plus c. Plus c. The next one, integration of f prime x times f x power of n. Okay, the answer is fx power of n plus 1. We increase the power by 1. Divide by n plus 1. The new power plus c. Okay, yang ini the third rule yang you all kena ingat. Okay, we go to the example. We have integrate 2x times x squared minus 3 power of 4. Okay, so we let fx is x squared minus 3. F prime x is 2x. The derivative here is the same. Okay, exactly the same as the remaining function. Okay, so back to the rule. We can use the rule. Therefore, integrate 2x x squared minus 3 power of 4 dx equal to, okay, fx power of n plus 1. For our case, we have x squared minus 3. Okay, for the question, we have power of 4. Therefore, the answer will be power of 5. Divide by n plus 1, the new power, which is 5 plus c. Okay, so we can get the answer by using the rule. Okay. And next question, we have ln x divided by x. Okay, so we let fx equal to ln x. Okay. And f prime x is 1 over x. Okay. So 1 over x here, okay, is the same as the remaining function, 1 over x. Therefore, integrate ln x over x dx equal to integrate 1 over x ln x dx. Kan? Okay, this one lah yang saya cakap sama tadi. Okay. And equal to, okay, so this is the pattern of integrate f prime x, fx dx. And the answer for the rule is fx power of n plus 1 over n plus 1 plus c. Therefore, for our case, it becomes, okay, our fx is ln x. Ln x power of 2. Because the original power is 1. Divide by 2 plus c. Integration of exponential function. Okay, we recall our derivative first. So, d dx of, let's say we have 3 power of 2x. Okay, the answer is copy the exponent times ln base. Ln 3 times derivative of the power times 2. Okay, so kalau you notice here, semuanya times, multiply. Okay, and for integration, kita tahu dia adalah opposite, right? Okay, so we have integrate, okay, for this case, integrate exponent ax plus b equal to, copy the exponent, okay, but we have divide by. Okay, if we refer the derivative, we have times and times, right? Okay, for integration, we need to divide. Divide by exponent ax plus b, the power is ax plus b. Differentiate the power, okay, will be a. So divide by a. And actually we have ln e here. But we know that ln e is 1. Okay, so we write divide by a only. And then plus c. Okay, but you need to make sure that the power of the exponent is a linear function. If the power is non-linear, so you cannot use this rule. Okay, so one more time, integrate exponent is copy the exponent, divide by ln base, and also divide by differentiate the power. Okay, part B, a power of bx plus c. Bx plus c is a linear function. The answer is copy a power of bx plus c divide by b. So how to get b? B is the derivative of the power. And then ln a plus c. Okay, c. Okay, rule part C. F prime times exponent f. Okay, integrate. We have exponent fx plus c. So you need to remember this rule. Okay, part C. Find the following integral. We can write 5 in front. 5 integrate exponent 5x dx equal to, okay, 5 copy the exponent, divide by, okay, ln e, ln base, and times differentiate power is 5 plus c for indefinite integral. And the answer is exponent 5x plus c. Okay, next one. Exponent 2x plus 1 and the power is a linear. Okay, so we can integrate directly. We will get, okay, copy the exponent, divide by ln e is 1 and differentiate the power. Okay, divide by 2 plus c. Okay, part C. Copy 3 power of x, divide by ln 3 ln base, and then differentiate the power. Differentiate x is 1 plus c. The answer is 3 power of x divide by ln 3 plus c. Part D. Integral of 5 power of 2x plus 1 equal to 5 power of 2x plus 1. Okay, we can apply the rule directly because the power is a linear function. Okay, divide by ln 5 ln base times differentiate power is 2 plus c. Okay, or we can write 5 power of 2x plus 1 divide by 2 ln 5 plus c, or 5 power of 2x plus 1 over ln 25 plus c. Okay, for part E, okay, we need to remember the rule part C. Okay, we have integrate f prime x exponent exponent f x dx equal to exponent f x plus c. Okay, you can refer rule part C. Which one? This one. You can refer this rule. Okay. And for this case, okay, fx equal to, look at the power of the exponent. So we have x cubed plus x minus 2. F prime x equal to 3x squared plus 1. Okay, the derivative here is exactly the same as the front function. Okay, so integrate 3x squared plus 1 exponent x cubed plus x minus 2 dx equal to, okay, we use the rule exponent fx. For our case, exponent x cubed plus x minus 2 and then plus c.